The Cognitech Tri-Suite software package includes Cognitech Video Investigator, Cognitech VideoActive, and Cognitech AutoMeasure. AutoMeasure is Cognitech's comprehensive image processing platform for accurately measuring objects or people. One of AutoMeasure's primary functions, 3D MultiView Measure, will be covered in this interactive tutorial. Welcome to the Cognitech AutoMeasure 3D MultiView Measure tutorial. Cognitech AutoMeasure is a tool for measuring people, objects, accidents, and crime scenes in any photo or video frame, provided that you can return to the scene to take additional photos or to take remaining object measurements. Only a single linear measurement is required when 3D MultiView Measure is utilized. This interactive tutorial will focus on helping you get started with AutoMeasure 3D MultiView Measure projects. Click Continue to begin the tutorial. All projects in AutoMeasure start with the Project Wizard. Click the Project Wizard icon now to open the Project Wizard. This is the Project Wizard. To start a 3D MultiView Measure project, select 3D MultiView Measure. 3D MultiView Measure is a method that allows you to perform measurements in an image taken with a known or an unknown camera, using at least two other images taken with a known camera. Click Finish to open the 3D MultiView Measure project. Measurements can be performed with AutoMeasure 3D MultiView Measure as soon as we have two pictures of the same scene from a known camera. It is not required to manually measure multiple 3D points in the scene. Only a single scale measurement has to be performed, where the distance between any two visible points has to be measured. This is an improvement on the single frame measure method, where the required measurements of at least 6 non-planar points is laborious and prone to errors. 3D MultiView Measure is a proprietary patented blend of the classical stereo photogrammetry techniques and the single-frame metrology technique, developed by Cognitech scientists in the early 21st century. Click the Load Images step from the Steps pane to load the evidence and test images. Click Open to load the evidence image and two test images. Calibration files must be created for each camera to be used in the measurement process in 3D MultiView Measure projects. Camera calibration estimates the following camera parameters: the focal length of the camera, the focal plane position of the optical center of the camera, the relative size of the pixel elements, and optical distortion parameters. Click the Load Calibration File step from the Steps pane to load a calibration file created from a camera calibration project. Click Open to open the Olympus camera calibration file. AutoMeasure allows for different camera sources in the same project. However, in this case, all pictures were taken with the same Olympus camera. Note, if no corresponding calibration file is available, you can assign an unknown camera to the image. All measurements will be done on the distortion uncorrected image and will yield less precision if geometric distortion is present. Click Associate Images to see instructions on how to associate the images in the image pane with the calibration file you just loaded. Click OK to continue. Right-click on any of the thumbnails to bring up the right-click menu and associate the images with the calibration file. All the image thumbnails are selected so that all images can be associated at the same time. Select the Olympus camera calibration file in the Associate With menu to associate it with these three images. When the correct distortion step is clicked, each image is distortion corrected according to its corresponding calibration file. Click the Correct Distortion step from the Steps pane to correct the distortion. The images have been distortion corrected. To get a closer look at the effect of distortion correction, double-click to open the first image. The Show Corrected Images checkbox will let you compare the distorted and corrected images. The Show Corrected Images checkbox is found in the Display tab of the Tools pane. Click the right arrow on the Tools pane to show to the Display tab. Click the Display tab. Toggle the Show Corrected Images checkbox on and off to compare the corrected and distorted images. We are now ready to start placing points. Click OK to move on. Click the left arrow to go back to the Drawing tab. Click the Drawing tab to open the Drawings tool. Accurate point placement is important. The most accurate point placements are at corners, but at this magnification, it is difficult to accurately place a point on a corner. Zoom tools have been provided, allowing you to zoom in for more accurate point placement. Select the Zoom In tool in the Drawings pane. To zoom in, click the image with the Zoom In tool. Now that this corner is easily visible, select the Add Point tool to place a point. Click the corner to place a point with the Add Point tool. Now you need to place corresponding points. Double-click on the second image thumbnail to open the second image. Select the Move Point tool to place a corresponding point on the second image. Drag the point to the corner in the second image with the Move Point tool. Double-click to open the third image. Drag a point from image 1 or 2 to the corner in the third image with the Move Point tool. To save some time, we have placed the rest of the points in the project for you. The next step is to set a scale measurement. Click the Set Scale step in the Steps pane to move on. We are now ready to set a scale measurement. Click OK to move on. The Measure tab includes the Scale Placement tool and Measurement tools. Click the Measure tab on the Tools pane to continue. A scale measurement must be taken between 2 points in the scene. In this example, we measured the elevator button panel. The length of the elevator button panel is 20 inches. Enter 20 into the Scale Value entry box and click Set Value. Select the Scale Placement tool to place the scale between the 2 points we measured. Select point 8. Now select point 1, setting the scale measurement. Once the scale measurement has been placed, click the Compute step in the Steps pane. Once the computation is complete, you can check the accuracy of your points in the Point table. Click the Tables menu on the top toolbar and open the Point table. This table provides the 2D position of each click in pixels and the 3D position in the World Coordinate System, along with the reprojection error of each click. Reprojection errors are color-coded. Green is accurate, orange is less accurate, and red is not accurate. One of the points we placed is red, meaning not accurate. This error should be corrected before continuing. Click OK to continue. The point in the second image was improperly placed. The green reprojection lines show where AutoMeasure estimated the correct placement of the point. Move the point to the proper location. Now that we have a fixed point, click the Tables menu at the top toolbar and open the Points table. Now all the points are green, meaning that all our points have minimal error. Low error will provide more accurate results. Click OK to continue. Click the Do Measurement step in the Steps pane to move on. This message provides several useful measurement tips. Click OK to move on. Click up in the Tools pane to see the upper section of the Measure tab. The Set Base Triangle tool is used to place a reference plane for making measurements. A base triangle is required for measurements. Click on the Set Base Triangle tool to set the base triangle. Select point 4. Select point 5. Select point 11, setting the base triangle. The Measure Height tool is used to make height measurements perpendicular to the base triangle. Select the Measure Height tool to start measuring the subject's height. Click the point at the subject's feet to place the bottom of the height measurement. Click the top of the subject's head to place the top of the height measurement. Height measurements on any image are automatically transposed on other images in the project. The height of the subject is measured at 58.258. The actual height of the subject is 58.25. Now that the results have been exported, click the Export Results step in the Steps pane. Click OK to export the images in this project. Congratulations on successfully measuring a person's height with AutoMeasure's patented 3D MultiView Measure technique. You can see how accurate and useful this technique can be in many circumstances. If you would like to start from the beginning, click Restart. For sales or technical questions, contact us at sales@cognitech.com or techsupport@cognitech.com, or visit us at www.cognitech.com.